In question 1, we are provided with an ANOVA summary table that is coming with multiple regression modeling or data analysis, and we want to figure out the MSR, which is the mean square regression, all right, out of this table. All right, so I just want to bring your attention to this table in your book. So the degree of freedom, for instance, 2 is this number k. So k is going to be 2. The 15 actually is n minus k minus 1. And the n minus 1 is going to be 17. All right. And the SSR is going to be 150. The SSE is going to be 190. And SST, the sum square total, is going to be 340. Now, to get the MSR, the mean square regression, that's what they are asking us for. So I need to divide the 150 divided by degree of freedom, which is 2, and that should be 75. So the answer here is going to be 75. Check it. We're good. Now they are asking you for the mean square error, and we're going to do exactly the same thing. We're going to follow the formula after identifying the variables. So the mean square error is going to be SSE, which is 190, and we're going to divide by degree of freedom, which is 15. So they are on the same line, you cannot get lost. And 190 divided by 15, let's try to do it on the calculator. So it's going to be 12.666. We went around to 4 decimal places. It's going to be 12.667. You can use Excel as well, that's good. So the F statistic right now, according to my formula, it can be the two values that we found, the MSR, which is 75, divided by 12.66, and so forth, right? So again, let's do it either the calculator, or we can do it even on Excel. So we can type in equal sign 75 divided by 12.6667. And that's going to give me 5.92104. They want 2 decimal places, so it's going to be 5.92. All right, that's good. Now we're going to decide what is our hypothesis testing. And as you notice here, we have the degree of freedom k, which is 2. That means there are 2 betas, beta 1 and beta 2. So the null hypothesis is always 80. All the beta, so beta 1 equals to beta 2 equals so forth all the way. If I have n of them, it can be beta n, and all of them equals to 0. And h1 is going to be at least one of the beta i's is going to be different than 0. All right. And this is for I is going to be equals to 1 all the way how many variables you have. If you have n x variables, it will be n of them. In this case, we have only 2. So we have beta 1 and beta 2 is going to be 0. And at least one of the betas is going to be different than 0. And that would be C, answer C. Okay. The p-value. All right, so the p-value, we're going to use Excel to do this. And the way to do it, you're going to use a function, equal sign, and the p-value is coming from a the p-value is coming from the f distribution. So you're going to be f dot distribution, and we're going to use the RT, which means right tail. And we're going to put the x value, the one that we found. So we can click on this value here, comma, and degree of freedom. They are the same degree of freedom that are provided here, the 2 for regression and 15 for the error. So you have to type 2, comma, 15. and close the parentheses. And that's going to be 0.0127. They want 3 decimal places, so it's going to be 0.013. Check it. We're good. So in this part, we want to decide whether we're going to accept or reject the null hypothesis. And obviously here, because we use the p-value and the alpha level of significance, which is 0.05, is easier to compare the alpha with the p-value. All right. So the rule decision here, we have the decision already made with the H0. All right. If I have f statistic greater than f alpha, and let me try to explain it. So this is going to be my f distribution, and what we call the f alpha, that's the f critical. That means this is where the alpha ends, and this is the value f alpha. Now the rejection zone gonna start from here, from the f alpha. We're gonna reject H0 from this side, otherwise we do not reject. Now if the f statistic is greater, it means the f stat is gonna be within this region, f stat. So if the f stat falls within the rejection zone, you reject. All right. Now the p alpha is explained as the same way as the f alpha starts or ends at the alpha level. The p alpha as well starts or ends this area is going to be shaded with the p value. So what we understand if the f stat is greater than f alpha, this is equivalent that the p value is less. You see the area is smaller than the alpha value. So if we have this statement, we can of course reject H0. All right. And since we have the p value is 0.0127 and the alpha value is 0.05, so here obviously this statement is true, and the conclusion will be reject H0. And that's basically it, right? So let's go back. We're gonna reject H0, and every time you're rejecting H0, you have sufficient evidence. And I think the best statement would be A. There is sufficient evidence of significant linear relationship with at least one of the independent variable, because the p-value, that's the statement we are looking for, is less than the level of significance, right? And let's check it, and we're good. So again, here on the previous question, why we want to reject? Because this is a proof that we are rejecting H0, which means not all the slopes are equal to 0. All right, we are rejecting this. So at least one of them is different than 0. That means there is a regression or linear relationship. All right. Okay, so now we are looking for r squared. So to find r squared, we need to divide the regression sum squared, so the SSR, and the SSR is going to be this 150, and we want to divide it by the SST, and the SST is going to be the total 340. And we can do the operation again on Excel. It's going to be 150 equal sign 150 divided by 340, and this is going to be 0.4412. We want to round to 4 decimal places, so it's going to be 0.4412. All right, so what the meaning of this? The meaning of this one, the coefficient of multiple determination indicate that we turn the 0.4412 into percentage, so that's going to be 44.12% of the variation of the dependent variable here, so which is dependent variable here, can be explained in the independent variables. So You can notice here this is plural and we have many independent. However, we have only one single dependent, right? Okay, so check it. We good. The adjusted r squared. So the formula. So this is our adjusted r squared formula, and I just want to bring to your attention that the n minus 1 over here, this one, is nothing other than 17. So according to your formula, we have here n minus 1. And on the other hand, we have n minus k minus 1, it can be the 15. So this is corresponding to n minus k minus 1. Of course, the top one is k. So if I'm going to use this, I have already calculated the r squared. So I just have to plug it into the formula. So this is going to be equal sign 1 minus parentheses again 1 minus 0.4412 and multiplied by 17 divided by 15 and close the parentheses again. I'm going to use a calculator. That's a regular calculator. So this is going to be 1 minus, open the parentheses twice, 1 minus 0.4412, close the parentheses, and then times 17 divided by 15. And this should give you a smaller value. All right, so with the r squared is smaller than the r squared. The r squared adjusted is smaller than the r squared. So this is going to be 0.3667. Okay, so done.